Hi, this is Around and Around. This is our carbon cycle day 2 video. Our warm-up questions were the following 5 questions. See if you can think about the answers to these from your past classes. Our questions are: what is matter? What are 2 examples of matter? When carbon left the atmosphere, thinking about the day that we pretended to be a carbon atom, what is one place it might have gone? How can carbon move from a plant into an animal? And where did your carbon atom spend most of its time if you were doing that carbon activity? All right. Please make sure you have your Around and Around packet out and available, and you can use pages 4 and 5 of your packet to help answer these questions. All right. If you were absent last class, make sure you use this class to try to get through some of the Pear Deck in that yellow folder. All right, so let's think about our warm-up. What is matter? It's anything that takes up space. And so 2 examples could be carbon, because of course we've been talking about carbon, or of course hydrogen or nitrogen or oxygen, any of the elements, right? Trees, humans, a desk, the floor, the window, a car, a rock, right? Anything that takes up space. So when carbon left the atmosphere, places it could have gone to plants, right? Leaving the atmosphere, going to plants. That would be photosynthesis, right? Going from the atmosphere as carbon dioxide into plants where it becomes glucose. It might have gone into the ocean through diffusion, or into freshwater also through diffusion. How could carbon move from a plant into an animal? We'll think about that. How does a plant get into an animal? Nom, nom, nom. That animal is going to eat. All right. And then you had to answer this question on your own. Where did your carbon atom spend the most of its time? Because that was unique to each person as they went through their carbon journey. All right. So, what are we going to learn today? We're going to continue to explore how carbon cycles between the living and non-living parts of the ecosystem. We're going to do that by collaborating and answering questions using the Gizmos simulation. And we have some practice and an exit ticket. And that's so that we can understand how matter, in the form of carbon, moves between the different spheres. And when I say the different spheres, I mean the biosphere, the geosphere, the atmosphere, and the hydrosphere. All right, think about what you did last class. You were pretending to be a carbon atom. And so, really, you were exploring how carbon can go from one part of an ecosystem to another. Sometimes you went from biotic to biotic, right? If you were in a plant and an animal ate you, then you were carbon that went from one biotic thing to another. If you were an animal that died and was decomposing, sometimes those carbon atoms end up in the atmosphere during decomposition, and sometimes they end up in the land. And so you were thinking about how carbon goes from one place to another. All right, in class, oops, this video really is available. Just a moment, though. So in class, can I make that go away? Maybe. I handed out, oh my goodness gracious, I'll try to fix that in a second. I handed out a page that had a list of vocabulary and some definitions. I'm going to just put myself on pause here. That's just a timer video that keeps being argumentative. I had a list of vocabulary: atmosphere, lithosphere, carbon cycle, and so on. And you were trying to match up those words to the definitions. So lithosphere is the one that we haven't really talked about. And so number 11 is lithosphere as you're filling out this piece of paper. I gave everybody that answer. Everything else you're pretty familiar with. Remember, a carbon reservoir is a carbon pool, or kind of a big bucket where we can find carbon that is either being stored or it can be released from that reservoir as well. All right, so back to slideshow. Looking in your packet, this was early on in your packet, I think it was the second piece of paper, we were reading this article about what exactly is the carbon cycle. And so we're going to refer to that a little bit. and have some discussions with classmates. And so on everybody's tables, we had these questions, and people were thinking about the articles and trying to answer each of these questions. So in an effort to make sure that we are collaborating, after each table filled out the answers to these questions, we switched papers, and each table then put a check mark if they agreed with the prior table's answers, or a question mark if they weren't sure or had a question about something. Okay, and so let's see if we can talk about these answers. So carbon is an atom, or it can be an atom. It's an element. It is a component of carbon dioxide, and it's the basis of life, is what most people wrote after looking through the article. What's the connection between volcanoes and the carbon cycle? If you look at page 2, when volcanoes are erupting, we are releasing carbon into the atmosphere. As more carbon enters the atmosphere, how does it impact the Earth? It's going to have an impact. Generally, it's going to impact global warming, increase global warming. How does carbon affect the ocean? Global warming itself can make the ocean layers rise. It can make our ocean's levels rise up. It can make the ocean more acidic, which makes it less of a happy place for some of the plants and animals to live, so it can decrease the available habitats in the biodiversity. Also, though, carbon, if it's in carbon dioxide, can be a good thing in the ocean, because carbon dioxide can offer one of the reactants for plankton and algae to do photosynthesis, right? Because photosynthesis needs carbon dioxide. Currently, do the oceans absorb, take in, or release more carbon? They're going to take in a whole lot of carbon, so they are carbon sinks. Sink, S-I-N-K is what I'm saying. And then during which season do carbon dioxide levels go up, and why? Well, in the winter, if we have fewer leaves on our deciduous trees, there's possibly going to be less photosynthesis happening. And so if there's less photosynthesis happening, it means we're not pulling as much carbon dioxide out of the atmosphere, right? Because less photosynthesis means those plants aren't taking that carbon dioxide out. So that is a possible season and reason. All right, so looking at your page in your packet that looks like this, we're going to think about your journey, your personal journey as a carbon atom. And so wherever you started, I'd like for you to put a star. Okay, and so for me, I put a star in the atmosphere, I think is how we're doing this one. Yes, and then if I look at the places that I went on my notes, and hopefully you did at least 10. Some people actually managed to go to 20 different locations, and some people didn't quite get there. So if I went to the atmosphere first, something happened when I was in the atmosphere, probably diffusion, and I ended up on the surface ocean. So I'm going to draw an arrow showing that I went to surface ocean as a carbon atom. When I was in the surface ocean, I then went into ocean plants, probably through photosynthesis, right? So I'm going to have an arrow going to ocean plants. And then I went to ocean plants again. And so after I went to ocean plants once, you can see my second arrow shows that I went to ocean plants again. And then maybe some sort of a creature ate that plant. And so the carbon went from an ocean plant to an ocean consumer, and so on. So I asked everybody to use arrows to show the path that their carbon atom followed. And then we talked about what might stand out in your journey. And some people said they got stuck in certain locations. And some people said, oh, I never even made it to a couple of these locations. So at each table, for some of the classes, I actually had people write down the number of times they ended up in each one of these locations. I wasn't able to do this with all of the classes, but you'll see next class we talk about the data that we got from looking at the numbers of times people went to different places. So if you were a class that was able to do this, I had you also enter this data into a Google form. All right, and so that just took just a moment if you were one of the classes that did this. All right. Why wasn't everyone's journey the same? Well, one obvious answer is you didn't start in the same location, right? So it kind of depended where you started, where you would go next. Because if you start as a fossil fuel, for example, you can't go immediately into the atmosphere, right? Something has to happen first. You have to be burned or I don't know, some change has to happen. If you start out as a plankton, you are not going to go from phytoplankton directly into, well, you might go into decomposition. It all just depends on exactly where you started, probably. And then different things can happen at different times. Think about the law of large numbers if you've talked about that in math. So remember that if I had had you do the carbon cycle, pretend you were a carbon atom every single day, every time you came to class this year so far, you probably would have visited more of the different locations, right? So sometimes a smaller sample, you only get a small bit of information. All right, so in today's green folder in Schoology, if you were able to record information about your carbon cycle, number of times you went, you would record that in the Google form, but not everybody did that. All right, so here is a video that I will have you watch.
Pine trees, bumblebees, and Swiss cheese, what do these all have in common? It's carbon. Carbon can be found almost everywhere. Find out just how important carbon is to life on Earth next on Real World. Carbon is not only the fourth most abundant element in the universe, it's also one of the essential building blocks of life. It's in our bodies and in our food. But what is carbon anyway?
Carbon is one of the basic building blocks of life on Earth. It's found all over the place, like in animals, plants, and it's also found in non-living material, like rocks and the atmosphere.
Carbon is important for many reasons, including providing lots of the power that we use. It's found in coal, it's found in fossil fuels, it's found really in all of our main sources of energy. We can find carbon in many different types of source pools. There's a lot of carbon in the ocean. That's actually one of our main carbon pools on our planet. You can find carbon in the atmosphere as different gases, such as carbon dioxide, and you find lots of carbon in the terrestrial areas, so in plants, in trees, or in soils.
So what else do we know about this carbon cycle?
So the carbon cycle is the cycle of where carbon goes and also how carbon moves from one pool into a different one.
Carbon cycle is a system, this Earth process, that transfers carbon from the plant material to the atmosphere, back to the plant material, from the oceans to the atmosphere, back to the oceans, and from far below ground, from fossilized carbon pools to the atmosphere.
So fast-moving carbon, for example, is what gets stored in plants. You have photosynthesis that happens, which is essentially really a mechanism by which plants are able to absorb carbon from the atmosphere, and they essentially use the carbon to make sugar, which is the basis of all carbohydrates. And that carbon that's fixed there in these plants is fast carbon.
Slower carbon will refer to, over time, sort of the integration of perhaps atmospheric carbon into the ocean and down into the depths of the ocean. One manner in which it's transferred from the atmosphere to the oceans might be through the photosynthesis that's done by plankton in the ocean, and then the consumption of that plankton by higher level species, and then the eventual decay of some of that organic material. Those species will, to some extent, decay and be transferred to the bottom of the ocean, where the carbon that used to be part of those species gets locked away in ocean sediments.
Humans have a huge impact on the carbon cycle because essentially we are changing how it is. We're taking a lot of these pools of slow carbon and burning it and putting it into the atmosphere. So we're really changing where the carbon is, and that has some big implications. So we're not really changing how much carbon is there. The amount of carbon is always the same, but what we're changing is where it is and what form it's in. So if you put the carbon, take the slow carbon, you burn it, and you put it in the atmosphere, it gets expanded, and the atmosphere is a much smaller pool than the ocean is, for example, or our terrestrial reservoirs are.
Humans have a really important role in the carbon cycle.
All right, so if you have not done this already, you want to take a peek in your packet and you want to try to summarize. Okay, so think about what you have learned about the carbon cycle, and you're going to write some information about the different ways carbon was removed from the atmosphere. How does it leave the atmosphere? What are some ways that carbon can go back into the atmosphere? And what are some ways that carbon was transferred between plants and animals? So take just a second to do that. You can pause the video. And hopefully you came up with some answers like, number one, if you were in the atmosphere, these are hints. How did you leave the atmosphere? These are just quick hints. And then if you were in the atmosphere, check to see where you were before that. What moved you into the atmosphere? You can still be looking at your journey from the last class. And then what were some ways that carbon was transferred between plants and animals? So now you can check your work here. Plants do photosynthesis, right? So we can move carbon out of the atmosphere through photosynthesis and also into the ocean from diffusion. What were the different ways that carbon was moved back into the atmosphere? That would be cellular respiration, usually done by animals. Actually, I shouldn't say usually, but by animals or even by plants, respiration. And then again, with the ocean, there can be diffusion. And what are the ways that carbon was transferred or moved between plants and animals? Well, if animals are eating plants, that's consumption. They are consuming them. They are taking carbon from plants to animals. And of course, then we know that animals later respiration, right? Respire to release carbon back into the air. All right, you can, excuse me, look for 8 differences here between these two. There they are. We had a gizmos on this day. And so if you go into Schoology, let me click fast and see if I happen to have given the instructions. Yeah. So you're going to go into Schoology. You're going to click on the waffle up on the top of your screen, and you're going to choose Clever. Log into Clever, and then you should see the gizmos icon. And hopefully it says carbon cycle, and you'll launch your carbon cycle gizmos. So the gizmos is I'm just going to give you some quick hints about that. You're going to start as a carbon atom in the atmosphere. Okay, and so it's similar to what we did when we physically moved around the room. If you are in the atmosphere, you can become part of the oceanic carbon dioxide, or you can become part of the land plants, right? Because through photosynthesis, you can go directly from the atmosphere to the land plants. Behind the land plants, there are some, I think it's soil and sediment. So there are some places that you can go directly from atmospheric carbon dioxide into another pool, but you can't go directly from atmospheric carbon dioxide into the power plant probably. And so if you try to click on something and it doesn't let you make a link, it means you just can't go directly there. If you try to click and it does allow you to link, it will give you information about the next item. So right now I've clicked on atmospheric CO2, and it's telling me that that's the carbon atom starts inside a carbon dioxide molecule, and you can click a location to choose where the atom will go next. Again, you can only click on places that it could realistically go. And if you need to reset at any time, you're going to click reset. Sometimes you're going to need to do that so you can start over and go to a different location. All right, so your packet has direct instructions, specific instructions on how you're going to do this gizmos. So you're going to answer the questions in the packet. Sometimes there are questions in a gizmos online. We are not asking you to answer those. Just answer the ones in the packet. All right, and so you're going to, again, you'll go to the waffle in Schoology, choose Clever and log into Clever, and then you'll see the Gizmos icon. When you click on that, you should still see a coral reef one from previous classes. You might have pond snails or something, but this time you're going to click on carbon cycle. You're going to click on the word launch and spend some time working on that. I'm not going to wait 20 minutes with this video, obviously, but you can pause the video while you're working on your gizmos. All right, so how did the carbon move from the atmosphere to land plants? If you click to land plants, it should tell you about land plants, and we know it's going from carbon dioxide. The carbon is going to go into the land plants. Photosynthesis will happen, and carbon moves from carbon dioxide gas into a glucose molecule. Okay, through photosynthesis. How did it move from animals back into the atmosphere? That's going to be through cellular respiration. Okay, cellular respiration. The animals are exhaling CO2. And why do you think a forest fire would cause carbon to move into the atmosphere? It's because all living things are made of carbon. It's the basis of life, right? And so when they burn, the carbon is released into the atmosphere. All right, these ovals in your gizmos, they represent pools or reservoirs of carbon, places carbon could be stored. Okay. And so which of these sources is going to add the most carbon dioxide back into the atmosphere? It's going to be fossil fuels. Okay, fossil fuels, when they are burned, are going to release the most carbon back into the atmosphere. All right, there is nothing to do on this screen if you were doing this as a Pear Deck, because some of the classes did, but you can go into the folder for today and try the exit ticket. Use your notes, of course. And thanks so much for watching, and just double check, make sure you're really understanding the vocabulary. If you had questions on any of the exit tickets so far, you want to make sure you go back to them. And in a few classes, you're going to have your test on this material. Don't forget, your test is going to include some questions on photosynthesis and cellular respiration, and also questions on the carbon cycle. It's going to have more questions on the carbon cycle. Thanks for watching.